So let's go over how we would do a graph that includes all the elements that we've talked about so far: a change in the amplitude, a change in the period, and a phase shift of some sort. Well, I go through a laundry list of materials, and here's what I look for if I'm doing this. First of all, I always check out what's my amplitude. Well, my amplitude, remember, is the absolute value of the value number multiplied in from the sine or cosine function. So in this case, that's 4. Now the negative indicates that there's going to be a reflection about the x-axis. So we're going to have a reflection. So we already know these problems. This will affect only the y values, by the way. How about the period? Well, the period is always found by taking 2 pi and dividing it by whatever is multiplied in front of x. So 2 pi over 3 is our period in this case. Now, one other thing that I make sure that I do is I get how far my key points are spaced from one another. And I do that by taking 1/4 of the period. So key points, and I'll write this out, key points are always found at 1/4 times the period apart. So 1/4 of 2 pi over 3 reduces, let's see, the 2 divides by 4 gives you a 2. 2 times 3 is 6. Pi over 6 points apart. All right, we've got our period, we've got our spacing for each of our key points. So now we need to look for our phase shift. And our phase shift is found very easily. So we find the phase shift by setting the argument of the cosine function. So we're going to set our argument 3x plus pi over 2 equal to 0 and solve for x. And that number will represent our phase shift. Well, working this through, of course, 3x equals negative pi over 2. And then dividing both sides by 3, actually much easier, multiply both sides by 1/3, gives us x equals negative pi over 6. All right. So how does that help us? Well, in this case, if we're looking for our x values are spaced pi over 6 apart, and our phase shift will start, it tells us that our starting point is not 0, but at negative pi over 6. So what we're going to do is we're going to start at negative pi over 6 along the x-axis, and we're going to add increments of pi over 6 to get our key point. So if we add pi over 6 right here, of course we're going to get 0. Adding pi over 6 again gives us pi over 6 as the next x value key point. Adding pi over 6 again gives us 2 pi over 6. Well, that reduces to pi over 3. And then finally, adding pi over 6 one last time gives us pi over 2 as our last key point within one cycle of the function. So this is one full period. Now, one good way to check whether or not you've got a full period, we said our period is 2 pi over 3, so we should subtract pi over 2 minus our starting point at negative pi over 6 is going to give us, let's see, 3 pi over 6 for pi over 2 plus pi over 6 gives us 4 pi over 6, and sure enough, that reduces to 2 pi over 3. All right, not so bad. How about the y values? Well, this is a graph of cosine. Normally, cosine, remember, has its key points like this, 1, 0, negative 1, 0, and 1. But since we're multiplying everything by negative 4, what's going to change is that we will multiply negative 4 times 1. So our first key point is at negative 4. Negative 4 times 0 remains 0. Negative 4 times negative 1 gives us positive 4. 0 times negative 4 gives us 0 again, and then negative 4 times 1 gives us negative 4 as our key point. So we go to our function's axis right here. We say our starting point is at negative pi over 6. That's our first key point within one cycle. 0 is our next key point, pi over 6. After that, we have pi over 3. and then one full cycle that ends at pi over 2. The y values range from negative 4 to positive 4. And following our table right here, within one cycle, our graph will pass through negative pi over 6, negative 4, 0, 0, pi over 6, 4, pi over 3, 0, pi over 2, negative 4. So here's one cycle of my cosine function. Within one period. So here we go. And we can see that in addition to what we've just learned about how this graph works, we could also see that our domain can be identified, since like all sine and cosine functions, unless we purposely limit something, it's going to be negative infinity to positive infinity. The range is found by taking the minimum value along our y, so that's negative 4, to our maximum value, which is positive 4, and this forms our information about the graph negative 4 cosine of 3x plus pi over 2.